Hey everybody, this is Larry. This is day 23 of the Leetcode challenge. Hit the like button, hit the subscribe button. And if you're wondering why there are two heads today, is because for some reason the sound didn't get recorded. So I'm gonna solve this problem, or I'm gonna comment on me solving this problem because the video taped okay, just not the sound. Anyway, interval list intersections. Given two lists of coast intervals, each list of intervals is a pairwise disjoint and in sorted order. Return the intersection of these two interval lists. Um, yeah, so this is a very standard problem. It comes up a lot, but basically you're given all these intervals, or you're given two intervals in this case, and and yeah, and I think I was just talking about the constraints, and the way that I like to solve this problem is by using the sweep line algorithm. And I think I was just making sure that the beginning and end interval is inclusive or exclusive. It doesn't matter that much. And also we're going over that 5 case where if you look at example 1, just want to make sure that like 5 appears in both, even though it is at the end of one list and beginning of the other. Um, and how do we convert this to a sweep line algorithm? Well, what I would like to do is use the a event-based system, or event-based system seems weird, but it's a event type implementation where we convert each interval in which the start point and the end point, we convert it to uh, just two different events, one with a start point and one with the end point. With the start point inserting a segment into the current list, and then with the end segment, removing one segment. So this is where you get the event is equal to, for each event for each interval or each segment in A and B, for each starting point, we add +1, and then for each endpoint, we do -1 for that reason. Um, and right now, the way that I did it here, I just concat A and B together and then put in the events and then sort them together. So what I was doing now is that I'm going over that segment at point is equal to 5 case where you have the end and then the beginning. So how do we handle this case? Well, we want to handle this case by putting all the +1s first, so that when you have two segments, we have the end of one segment and the beginning of the other one, the beginning of the segment first, so then we have that overlap of two segments. So that's how I handle that case. And then how I implement that change is just by changing how we do the sorting. Yeah. So I'm just going over through that now. And I was just thinking about if there's a cleverer way to do it, but I was like, nah, just change how you sort it. And I was talking through how, yeah, how if you just do the +1 first, it should handle this case, because then you will always get the 2 before the -1 on the edge case. Literally the edge case where A and B intersect, but at the edge. Uh, but yeah, I think that's what I'm talking about now. And I think I was just talking about how to think about different ways of maybe sorting it, but I was like, I think at the end I just said this is okay. Let's just sort it that way. Um, yeah, if we have the +1 first, then it should always be okay. So we do it this way. So yeah, I guess the live tape I talk a lot more. I actually don't remember what I was talking about, but wish I did though. But yeah, we do a lambda function as a sorting key. We still sort by the event point, and then we just do the negative of the second event point, so that we get the +1 first, because it sorts by min, right? And just look at the double checking the events, and that seems like it'll be okay. Um, yeah, and then now we can look at each event one by one, um, by and now we're giving the the sweep line algorithm. Now we can think about, okay, for an intersection, what does it mean to have an intersection? Well, in this case, it means that an intersection means that two segments live on it at the same time. And now I'm just typing some variable to keep track of how many the current ongoing situation. But yeah, an intersection means that the two segments inside the current overlap, and that's what I am trying to keep track of here. So the current, we just add the delta, so to keep track of how many segments are in the current, current sweep line. And then now I think about, okay, if that means 2, right? Then okay, we could just set it to, we could just do a check. If it's equal to 2, this is good. We just add plus, because delta has to be plus 1, because there's only one way to get the current is equal to 2. And in that case, well, we saw it. What does 2 mean, right? That means it is the beginning of a segment. So we just set the start is equal to x. And then later we also check, or now current is equal to 1, and delta is equals to -1, because this means that it went from 2 to 1, meaning to differentiate it from going from 0 to 1. And just to write out that case, and in that case we can append the current segment, and the current segment began at start. So that's what I do now. Yeah, and start at X. Hit the like button, hit the subscribe button while you're sharing. How did you do it? Let me know in the comments what's the complexity, and let me know how you solve this problem, if it's okay. And then we restart start. But yeah. Anyway, and then that's it. We return results, and that's all we need. I was thinking here whether there is a case where you end a segment with, you end the entire processing where current is equal to 2, then you might actually have to check that if current is equal to 2 at the end, that you have to do something to end the segment. But in this case, it cannot be true, and that's what I'm saying here, because you're always going to have end segment, and end segment will always subtract them, so you cannot end at 2. In fact, you always have to end at 0, because that's how the input is given, right? So I test these. I was like, look at input. You can have 0 for A or 0 for B, number of elements. So I add that to the testing. Ran the cases and then submit, and it was good. So a little bit 10-second spoiler. But yeah, so what is the complexity? So the complexity here is n log n. It's going to be dominated by the sorting. I think I scroll down in just a second. I think set the one-time complexity. Space is going to be O of n because you have 2 entries in events for each item in A and B. So that's O of 2n, which is O of n, where n is the number of elements in A plus the number of elements in B. So can you do better? Well, yes, you can do it in linear time, because you can actually just do the 2-finger algorithm, meaning put a finger on A, put a finger on B, and then slowly merge them in a very edge casey way. And you could also even do it in the events way by having the 2 fingers algorithm. Just you can merge the, yeah, I think I'm just running out. And you could even merge the events that way with 2 pointers, and then that will save you a sort. But I like to do it this way just because it keeps things independent. And in competitive programming, this is, for me, I feel like it's much less error prone. So I prefer to do it this way generally. Even in an interview, you just tell them both the solutions and then try to figure out which way you prefer. But yeah, but overall, a good problem. I like this problem. And also, the benefit of really learning this sweep line algorithm is that if you do it with events, you can actually do other things with like unions and XORs and other type of operations, where all you have to do is just change the conditions of where these segments start and stuff like this from line 17 to 21. But yeah, but that's all I have. Hit the like button, hit the subscribe button. Let me know what you did, which problem you did. Let me know how you solved this, and I will see you later. Bye-bye.